So we're going to break the brain vasculature down into the arterial flow and the venous flow to make it a little bit more manageable. While it doesn't seem like a lot of anatomy here, we're going to be going over so many different images of this same anatomy in several different views, so you really start to understand the brain vasculature that I think is going to take more time. So let's start reviewing that now. So the circle of Willis, which is what we're going to study during this lecture, is the area right here in the center of the brain that's comprised of several different vessels, and I'm going to show you how we get to this point here, to the circle of Willis. So starting with the aortic arch, and you may remember this image from when we were studying the neck and the chest area. So this is the aortic arch, and from there we have the brachiocephalic trunk going to the right, the left common carotid, and then the left subclavian artery here. And coming off the brachiocephalic, and then as this becomes the subclavian, coming off of that is the right common carotid. So we have the left and the right common carotid arteries, and then they branch into the external and internal common carotid on each side. So left, external, and internal common carotid. And as a common carotid comes up, it does a little turn through the sphenoid and goes up through the petrosal area of the sphenoid here, and then keeps going up through the cavernous sinus, and eventually branches into the middle cerebral artery, which goes off here to the left, and the anterior cerebral artery, which goes up the page here a little bit. This is actually anterior, as you see the head tilted back. And so the same thing happens over here. You've got the right common carotid branching into the right external and internal common carotid, and it goes up through the sphenoid, up through the cavernous sinus, and branches into the right middle cerebral artery and the right anterior cerebral artery. And then coming up off of the subclavians again on each side is the left vertebral artery and the right vertebral artery, and those course through the cervical foramen and go up and do a little turn right at the base of the skull here as they come up through the foramen magnum. They join together to form the basilar artery, so they both come together into a singular artery called the basilar artery, and this runs anterior to the pons. And then the basilar artery terminates at the branches for the posterior cerebral artery, and the posterior cerebral artery turns to left and a right posterior cerebral artery. And then connecting the posterior cerebral artery to the middle and anterior cerebral arteries is this posterior communicating artery here on each side. So the left posterior communicating artery and the right posterior communicating artery. And then in between the anterior cerebral arteries is the anterior communicating artery here, and it's a very small artery, and you can just barely see it because of this black dot that's here on this image, but it's right there, anterior communicating artery. Netters also has a nice view of that, and you can see all of the extra vasculature as well. So while this one does get a little bit busier, it is nice to have all the anatomy visualized. I wanted to take you through this one more time. So this is the brachiocephalic trunk branching into the right subclavian artery and the right common carotid, and then the left common carotid and the left subclavian. And then coming up here, the common carotid branches into the internal and external on each side, internal and external. It comes up through the sphenoid and through the petrosal bone of the sphenoid sinus, and then branches into the middle cerebral artery and the anterior cerebral artery. And here you can see the anterior communicating artery. It's a little bit bigger in this image than it was in the last drawing. And these anterior communicating arteries are very narrow because they are going up through the falx, and so that's they join together and become much closer together, whereas the middle cerebrals are going out towards the lateral parts of the brain. Also, I wanted to point out that on the basilar artery, here are the vertebrals coming up again from the subclavians on either side. and the basilar artery turns, I'm sorry, the vertebral arteries turn and become into the basilar artery. There are many branches off of that basilar artery that are going back to feed the cerebellum. We're not going to focus too much on those right now, so as long as you know the basilar artery and the posterior cerebrals, the posterior communicating on each side, the middle and middle cerebrals and anterior cerebrals on each side, and then the anterior communicating, as well as the common carotid that's coming up here and branching into the middle cerebral and anterior cerebrals, then you'll be fine. But I just wanted you to know that there are more branches coming off the basilar artery that we're not going to focus on right now. And then also in netters, there is an MRI, contrast enhanced MRI of the brain, and this looks very much like the schematic view, so I wanted to point that out so that you can visualize what the vessels really look like. You've got the brachiocephalic trunk here and the left common carotid, the left subclavian, coming up, branching into the internal and external carotid arteries. The internal carotid arteries come up, and we're cutting it off before they branch into the middle cerebral and anterior cerebral. So we're actually not seeing the circle of Willis on this, but we're seeing the vessels that go into the circle of Willis. And then you have the vertebral arteries here on either side, and you can see this vertebral artery may not be quite as flush with fluid as on this side, and there may be something anatomically wrong, or something that's an issue with this vessel, some sort of trauma perhaps. And as you come up and feed into the basilar artery, you still see that the vertebral is not quite as thick or as strong as it is on this side. And then you've got the basilar artery here. In this view from Netters, we are looking at the brain from the inferior side, and we looked at an image similar to this when we were looking at the cerebral peduncles, and the image then had the brainstem removed. But here we have an intact brainstem. On the left side, we have an intact cerebellum and temporal lobe, but on the right side, they've cut away the anterior portion of the temporal lobe as well as the cerebellum, and that way you can see the middle cerebral artery and then also see the posterior cerebral artery and how it comes back to feed the posterior cerebrum. So taking a look at the brainstem here, you've got the right and the left vertebral arteries that come together to form the basilar artery. And there are several vessels off the basilar artery that help to feed the cerebellum. But where the basilar artery bifurcates, it becomes the left and right posterior cerebral arteries. And then from there, that's the beginning of the circle of Willis. This is the left posterior cerebral artery, and then you have the left posterior communicating artery coming up to the internal carotid artery, and the internal carotid artery comes in to form the middle cerebral artery and the anterior cerebral artery. So internal carotid artery, middle cerebral artery, anterior cerebral artery, and then this little connector in the front is the anterior communicating artery. So then on the right side, you've got the anterior cerebral artery, again the anterior communicating artery that we just went over, the right internal carotid artery, the right middle cerebral artery, the right posterior communicating artery, and the right posterior cerebral artery. So this little dotted line all the way around here is a circle of Willis. Note that it is around the region of the sella, so it sort of encircles the sella. This is the pituitary gland and the optic chiasm. This is the optic nerve. And so the anterior cerebral artery runs superior to that optic nerve before it joins closer together with the other anterior cerebral artery and runs superiorly up through the falx. So just be aware that circle of Willis is right in the near vicinity of the sella region, in the pituitary region. This image in e-anatomy is an illustration of a similar view as what we saw in the previous slide, and it also represents a similar image to the one that I discussed before, where we had been looking at the cerebral peduncles here. So on the right side of the brain, we have the intact temporal lobe, and on the right they have removed the temporal lobe. most of the basilar artery has been cut away, and you don't see the vertebrals. So this is where we'd be coming up to, the basilar artery would be coming up and branching into the posterior cerebrals, going back to feed the occipital lobe. And then you have the posterior communicating arteries on the left and on the right. And the common carotid is coming up and branching into the middle cerebrals, going in through the sylvian fissure, and then branching again. And then the anterior cerebrals come up and in through the falx. And then the anterior communicating artery is joining the two anterior cerebral arteries. So it's just another view of the circle of Willis. One last drawing of the circle of Willis, focusing just on that area. This is a great one for you to study and to draw yourself and to really get to know well, so that you are familiar with it for the exams and just in general for imaging. So we've got the basilar artery again, the posterior cerebrals, the posterior communicating, the internal carotid as it comes up here and then branches into the middle cerebral and anterior cerebral, and then the anterior communicating. And then this puts it around the region of the sella with the optic chiasm and the optic nerves here on either side. And then you've got the left and the right middle cerebral artery and the middle carotid coming up. You can see the pituitary gland, and this is the region again of the sella, and this is a cavernous sinus, and that's where the carotid artery comes up through the cavernous sinus. And the cavernous sinus is a venous structure. It is part of the drainage for the brain, the venous drainage, and we will be looking at that in the next lecture. This is a lateral view from the patient's right side, where we're seeing the brachiocephalic trunk here, and coming off of that is a common carotid artery and its bifurcations into the external and internal carotid artery. And you can see how it comes up through that petrous bone and into the cavernous sinus shown in blue here. And then it terminates as a middle cerebral and anterior cerebral arteries come off of it. And then the vertebral artery as well. You can see the vertebral come up through the cervical foramen, and how it does a little turn as it goes through the foramen magnum, and then it joins together with the left vertebral artery to join the basilar artery. Here's an anterior view from Netter's to show the circle of Willis with the brain surrounding it, as if you were looking at the patient, and they're upright. So we've got the right and the left vertebral artery coming up to the basilar artery, going into the posterior cerebral arteries, left and right. The posterior communicating artery looks foreshortened in this image just because of the angle that we're looking at it from. But there is a posterior communicating artery there, much smaller than we're used to seeing. The middle cerebral artery coming out here, the right middle cerebral and the left middle cerebral. The internal carotid artery has been cut here, and that's where it would terminate as it comes up. And then the right and the left anterior cerebral arteries and the anterior communicating artery here. In the upper image, you can see how the left temporal lobe has been left in place, but the right temporal lobe has been pulled back so that you can see the middle cerebral artery going through the sylvian fissure. And you can see a coronal slice of that. They've sliced through the brain so that you can see the brain behind it, but you can also see what's happening right there in this area of the brain. So you can see the middle cerebral artery as it flows laterally and then also superiorly. And then you can also see the corpus callosum here, that connection between the right and the left hemispheres of the brain, and then the falx and the pericallosal arteries, which are peri meaning near and callosal meaning callosum. So pericallosal arteries, which are branches of the anterior cerebral. So looking at the schematic view again as we go over the wording of the circle of Willis, the vertebral arteries, the arteries here, right and left vertebral artery, course through the foramen of C1, so they come up through the foramen of C1, turn and enter the cranium through the foramen magnum, coursing superior and medial. So as they go superior, they're also coming medial so that they can join together just at the inferior aspect of the pons become the basilar artery. And the basilar artery is formed by the junction of the two vertebral arteries, located anterior to the pons, we'll see that in the next slide, and posterior to the clivus, which I have shown you on another slide as well. It terminates just inferior to the diencephalon, where it becomes the posterior cerebral arteries. So it's near the mammillary bodies that it becomes the posterior cerebral arteries here. So this image shows you how the vertebral arteries come up and join to form the basilar artery, and that runs directly anterior to the pons and posterior to the clivus here, and how when it gets closer to the mid part of the brain it's going to have to branch because it can't go straight up. So it branches into those posterior cerebral arteries here as it branches around, and eventually that will feed the occipital lobe of the brain. Also within this image you can see the nerves and their origins. So you can see the 5th through 8th in the pons, and then the 9th through 12th down in the medulla. So it's a nice image for both the arterial vessels as well as the nerves that are in the brainstem. So we've got a couple T2 weighted MR images here, this slice being more inferior than this slice. And we've got the foramen magnum. You can see some cerebellar tonsils here in the posterior portion of the image, as well as the vertebral arteries, the right and the left vertebral arteries. So you know you're in the area of the medulla, because we have not gotten into the basilar artery in front of the pons, anterior to the pons yet. So coming to this slice here, we're a little bit more superior. You've got the pons here, and the fourth ventricle here. We've got a little bit of the vermis of the cerebellum, and then you have the basilar artery. And then here is the sella. You've got the pituitary gland here, and on either side of that are the internal carotid arteries. And this would be where the internal carotid arteries come superior, and then they make that little curve anterior and then curve back around posterior. And at that point in time, they are almost horizontal to your image slice, and that's why you're seeing the full length of the slice there and not just one dot here as you would with the basilar artery. So I'm going to go back a slice just for a moment. So this is where you're going to be seeing that internal carotid artery that way, is when you take a slice right through here, and the internal carotid wow, I'm having trouble with that tonight. Carotid artery is horizontal to your image. So some wording to help you with the internal carotid arteries. They course through the carotid canal of the sphenoid bone, along the carotid groove of the temporal bone, and within the cavernous sinus. Remember, that sits just on either side of the sella and the pituitary gland. They terminate to form the anterior here and the middle cerebral arteries. So anterior and middle cerebral arteries. And then the circle of Willis is the ring of arteries that's surrounding the pituitary and optic chiasm, allows for collateral flow in the event of an occlusion. This is a MRA of the circle of Willis. You can see the vertebral arteries, the basilar artery, posterior communicating arteries, and the posterior cerebral arteries and posterior communicating artery on the right. On the left, you don't see that posterior communicating artery. So there may be an occlusion there. There may be that may be normal for that patient. So that's just something to be aware of, that you don't see it on that side. You can see the internal carotid arteries and the middle cerebrals going off on each side, right and left, and then the anterior cerebral arteries coming anterior, and then they'll run superior after that. I like this image on the right because it shows you how small the area of the circle of Willis is. So we've got the cerebral peduncles here, and you know the pons is just inferior to that. So your basilar artery would be here, and your anterior communicating artery here. So your circle of Willis is just this area around the sella and the pituitary. It's a very small area. And then you would have your posterior cerebral arteries coming here back to feed the occipital lobe, your middle cerebral arteries on either side going laterally in the brain, and then your anterior cerebral arteries coming anterior and then moving superior, as well as your anterior communicating artery. Posterior communicating artery here between the posterior cerebral and the middle cerebral. Another nice 3D MRA. This is looking anterior. So this is the anterior view looking directly on at the patient. Got the basilar artery here, posterior cerebral arteries on either side. Can't quite see the posterior communicating artery because of the angle. We've got the internal carotid arteries and the middle cerebral and the anterior cerebral as well. So the anterior cerebrals course anterior and medial, so they start coming towards the midline of the brain, superior to the optic chiasm, and I showed you that before, superior to the optic nerves. The middle cerebrals course lateral through the sylvian fissure, right there. The posterior cerebrals course posterior around the cerebral peduncles to feed the posterior brain. The anterior communicating artery is singular, connects the two anterior cerebral arteries. And the posterior communicating arteries are bilateral. Both sides connect the posterior cerebrals to the middle cerebrals. And we'll move on to the venous structures next.